Welcome back, students, for the units on right triangles and trig. We're going to do video 3 for trigonometry, and hopefully we'll learn some stuff. I've been talking a lot because I'm trying to make sure we understand everything, and it's kind of challenging. So in the past two videos, what we covered were what are the trigonometric ratios, and then in the last video we talked about using those trig ratios as operations to find distances. And so now what we're going to do is using the inverse ratios. Okay, so remember what we talked about before. We have our sine, cosine, and tangent. They're all ratios of segment lengths, but they can also be operations, something we do to an angle. And if they are operations or something we can do to an angle, guess what we have? We have inverses of those operations. So we can use the inverse operations for these angles as well, for these ratios as well, I mean. And so that's what we're going to talk about today, and it might get a bit tricky, so let's see where this can be used. All right, so now what we're going to do is use the trig ratio inverses. Okay, so here's our first question. We have a diagram here. We've got a right triangle with a couple segment lengths. The question is, what is the measure of angle x to the nearest degree? So now what we're going to do is look for the measure of this angle. Okay, so what is the measure of angle x to the nearest degree? Now, how are we going to find out the angle measure, dag-nabbit? And that, my friends, is where the inverse operations come in. Okay, so a note. Remember that trig ratios of an angle give you a ratio, right? So you can take the sine of an angle, it gives you a ratio. You can take the cosine of an angle, it gives you a ratio. But if you already have a ratio and are looking for an angle, you use the inverse. Okay, now what in the world is the inverse of each of these functions? This is what it looks like. The inverse sine, sine to the -1, or cosine to the -1, or tangent to the -1 of some ratio. It's going to give you an angle. Okay, so if you take the inverse sine, also called an arc sine, or the inverse cosine, also called the arc cosine, or the inverse tangent, also called the arc tangent, it will reveal to you an angle. So if you're looking for a ratio of lengths, you use the function. If you're looking for an angle, you use the inverse. Now, what is the inverse function? You will see normally it's like right above a shift key or a second key on your calculator. It's right above it, right? Sine to the -1, cosine to the -1, tangent to the -1. Those are your inverse functions, and I'll show you how they work, okay? So back to this question. Here we have our diagram. We're looking for the angle here, and we have our given sides, 6 and 10. Now, what are those sides in relation to the angle? Hopefully you see that 10 is the hypotenuse. I hope you see that. And hopefully you see that the measure of 6 to the angle in question is opposite. So what we're looking at is the opposite and the hypotenuse. And remember Chief SOHCAHTOA. Okay, so Chief SOHCAHTOA comes back. Opposite and hypotenuse deal with sine. So what is happening here? What's happening here is that we have our relationship. What it means is that the sine of x is going to be equal to 6 over 10. The question is, how in the world do we find out what that measure is? And the way we do this is we use the arc sine or the inverse sine. So how does that work? So what we're going to do is have 6 divided by 10. We have our value, of course, 0.6. And what we're going to do is take the inverse sine. So what do we do with that? Our shift key or our second key, and then the sine button, or wherever you see on your calculator, sine to the -1. And it gives us a number that looks like it would be an angle measure, right? In this case, 36.869. Okay, so it's 36.869. That is actually what is showing us is the degree measure of that angle. That would give us 6 and 10, okay? So that's how that works. Remember, we can use the inverse function to find out a degree measure. So what is the measure of angle x to the nearest degree? 36.8 means we're going to bump that up to 37. So the measure of angle x is going to be 37 degrees to the nearest angle. to the nearest degree, I mean. And that is using the inverse trig function, right? Isn't that cool? Well, I don't know. Let's try it again. Let's do another one. So the same question, what is the measure of angle x? So here's another diagram, and we're going to look at angle x. So once again, we have our angle x here. It's all about perspective. When we consider angle x, what are we looking at? Hopefully you see that 20 is the hypotenuse. 15 is adjacent. Yes, it's adjacent, right? 15 is adjacent. So what are we going to do? We have to find the measure of angle x to the nearest degree. So what do we know with the given information? We have adjacent and hypotenuse. Adjacent and hypotenuse means we're going to be dealing with the cosine function now. Okay, so the relationship here is the cosine of angle x is 15 over 20. So what do we do with that information? The same thing we did previously. It's time for the handy-dandy calculator. We have to use the inverse cosine, or the arc cosine, inverse cosine. So we have 15 over 20, or 15 divided by 20. We have our value, 0.75. And what we're going to do is find the inverse cosine. So the shift key and the cosine button. And we have a degree measure. Okay, it's 41.409. Okay, 41.409. And we are rounding to the nearest degree. So the nearest degree, 41.4, that ain't enough to bump us up. So it's going to stay that our measure of angle x is 41 degrees. And that is how we use our inverse function. Okay? More practice, shall we? Yes, because this gets kind of tricky and fun at the same time. All right, so now we're going to be using our ratio inverses. So here's an example. Okay. Now the question is, what is the measure of angle y to the nearest degree? So let's first find angle y. Right? So we have angle y is there. What now are the two segments that we're looking at? Hopefully you see that for angle y, 100 is not the hypotenuse, it's the opposite leg. And 41 is the adjacent leg. So what is the trig function in question? It's going to be the tangent function. Remember, Chief? SOHCAHTOA. The tangent function is what deals with the opposite and the adjacent. So we're going to be looking at the tangent of angle y, and the tangent of angle y is going to be 100 over 41. And now we're all set to find the degree measure. How? Calculator work. Okay. So the tangent of y equals 100 over 41. So 100 divided by 41 equals, and then we're going to do the inverse tangent. And that gives us the degree measure of 66.7. And the question is about the nearest degree. So guess what that 0.7 does? 0.7 bumps us up to 68 degrees. So the measure of angle y is in fact 68 degrees. And that is our measure. Right? Cool. Yay, practice. Let's do some more. Let's do some more. All right, so another question here. Different diagram. Okay. The question here is, what is the measure of angle x to the nearest degree? Here's angle x. What are we looking at? Okay, so it's all about perspective. 18 is the hypotenuse, and 13, hopefully you see, is adjacent to x. Okay? So if we're talking about adjacent and hypotenuse, you better know by now it's cosine. Cosine of x is going to be 13 to 18. All right, so how do we work with that? Well, because that's going to be a sloppy number, isn't it? Well, perhaps 13 divided by 18 gives us our, as you called it, a sloppy number. We're looking for the cosine. So we're going to take the inverse cosine, and it gives us a degree measure. I mean, it looks like 43 point something, right? That's a degree measure, but we're rounding to the nearest degree. 43.7 knocks us up to 44. So the missing angle measure, the measure of angle x, 44 degrees. Okay, so now we know it's 44 degrees. Hooray for inverses. More practice. Yeah, buddy. Oh, no more practice. I love this question. Oh my gosh, I love it. I love it. I love it. Okay, quick quiz, quick quiz. Look at this question, folks. A winner. Can a sine be greater than 1? Explain. Can a sine be greater than 1? Well, what is the sine? Remember what sine is? It's the opposite over the hypotenuse. So the sine is the sine of anything, we'll call it angle alpha, the sine is the opposite over the hypotenuse. Can a sine be greater than 1? Well, what is the longest side of a triangle, of a right triangle? The longest side is the hypotenuse. So in order for the sine to be greater than 1, that means the opposite side would have to be longer than the hypotenuse. And guess what? That is impossible. The opposite side cannot be longer than the hypotenuse. So I love this question. The answer, of course, no. A leg of a right triangle cannot be longer than the hypotenuse. No, it cannot be greater than 1. And this has a lot of neat advanced trigonometric qualities behind that question. But that's the answer. So hopefully you learned some stuff about inverse ratios, right? So that was fun stuff, yay, with the calculator. But I think more importantly, I still remember how excited I was to know what these buttons meant. So that was cool. Hopefully you feel the same thing. Anyway, done with the lesson. Hopefully you enjoyed trigonometry. We're going to wrap up the unit for the next set of videos. Take care.